So I'm Mel Muldowney. I'm a teacher, work in a school in Stratford upon Avon. So we're going to have a look specifically at the GCSE statistics. I'd like a little spreadsheet, as most maths teachers do. So most of this will be based on the data from the summer 23 papers. So in terms of, rather than just go, oh, these are the topics that are at the end of this scheme of work, or these are the last 4 chapters in this statistics textbook, or this is based on what I think is really tough to teach. I thought, let's do this properly and try to get it based on some evidence. So I started looking at the questions that students found difficult in June 23, started looking at the misconceptions, some of that's based on my own experience, some of it's based on looking at scripts. And then I thought, but actually, some of the best things I've ever got from CPD sessions is initially has been a resource I can use, that literally throw it in the photocopier. But then some of it takes months and years to come to fruition, that you go, actually, that was that idea that was seed was planted years ago. So you might have a different perception of what are tough topics or higher tier topics. So it is based on data. I took the skills map, which is available in the Emporium. There's one usually for every maths qualification. It's at a high level there, you'll see. So this was the June 23 higher paper 1, paper 2. But then if you click on the bottom box, you see that the part question has been broken down into more detail. If you haven't seen those, they expanded and got really useful more recently, where we could see what the average, so the mean score, you'll see across the top the grades, and the scores underneath, it's showing you the mean score that each of those grade students got. That's not to say that a grade 4 student would need to get 18.36 on that paper, because the grade boundary would be somewhere between 3 and 4, because it's the average grade 4 student, or the middle grade 4 student. So we've looked at that, and then it does go into a lot more detail. Important to share, when I did the feedback session on the summer papers, I shared that, and I thought it was important to share again. So we've got the ramping within the papers, and that's paper 1 and paper 2, and you can see it's got all the subsections. I then sorted it based on the performance of the students for each sub-part of the question. So you could see that actually question 1 isn't all the easiest question, and so on. The ramping happens within a question. So there is obviously ramping. And just for students to understand, especially if you're in a new centre, looking at delivering stats, because this is the overall ramping of the questions. So there was 40 subparts to paper 1. And you can see that and this is taking the Edexcel mean for the whole paper. So the first, and I just called them parts 1 to 40 rather than question parts, because it was the easiest way of getting that ordered across the bottom. And you can see that the performance is up and down within a whole paper, which is very different to GCSE. We would expect GCSE to have a higher performance at the beginning, going down to the end as the questions got more difficult. But I think it's important we get the message over to students that just because one part of a question is difficult on stats, that the next question is a different topic, and it doesn't necessarily mean that topic is more difficult. That within questions, the difficulty goes up and down. So the experience that the students get is very different to a GCSE. And I say that because if we don't tell them, they'll notice it, but let's sort of explore it with them. And if they get that they go in there expecting it, it will make the experience a little bit nicer for them. And then you can see the same on paper 2, that ramping or that performance goes up and down within subparts of questions. You'll see that there was 37 parts of the paper. And then you can see, so part 9 performed the worst on the paper. Again, telling them that is to be expected, that we would expect students to perform less well on different parts within a certain question. And it's about knowing each topic really well. And you can see here, the 4th column across where it says performance 1 to 31, that's just showing what the average student got. So for all students, rather than, I could have then cut and sliced this and gone, oh, let's just look at what the grade 9 students did or the grade 8 students. I had to go with all students. And started looking at, is there some kind of topic, there's some kind of theme running through this, that perform worse than others. So you can see their question, it was 2B, that was the one that performed the best. Because what we're looking for here, there's two aspects to it. One, I could deliver you topics that they perform really well at. But the thing is, they're probably performing really well because there's loads of resources out there. And as a teacher, I probably want something that will help me improve the averages or improve their performance. And then paper 2, you can see that question 7A was the best performance with 95%, but then 9E was the worst, calculating the IQR. I think it was probably a bit more complex than just calculating the IQR. So question 3E was the 9th position in the paper. So that was that one, I think, that we've just seen, but it was the worst performing part of the paper. So that's where I started. Got to love a spreadsheet. But like I say, I could have cut that anyway. So if you're interested, you can see this is paper 1 and it was sorted by grade 7 students in terms of the order that they found it difficult. I just thought I've got to cut this off somewhere and went with the average student or the all student averages. It's lots of way of doing it. And I came up with 4 or 5 different topic areas they performed really badly at. And the first one was normal distribution. And I'll go through it, all the topics, and you'll see at the end that I have something to help you. So I thought the best, if I put myself in your position, say, okay, so what is it the kids are doing? What do we need to do to get better? On the Emporium, and I think, again, really good resource is the work solutions, because it's difficult to know what is it that the examiners are looking for. I think almost all of the sittings for the new GCSE in stats have got work solutions. If not, and there's a set you particularly want, let the team know and we'll see if we can put it together. They're not an exhaustive set of solutions. It's meant to give you an idea of the kind of thing that students should be writing. So this particular topic, part A, they didn't know that they were being asked to define the rate, or they said incorrectly that 19.61 was the weight, and a small number of those that attempted to interpret the gradients incorrectly stated it was the increase per length. So they needed to be talking about the rate. And you see the word in there is for every 1 centimetre snout length, the weight of the snake increases. It's almost a definition of how do we, giving them an example of the kind of words they use. A lot of the things that we can do to get better or make our students better is to do with interpretation. And I think it's about giving them worked examples, giving them, for want of a better phrase, and I'd probably roll my eyes at this, sentence starters. And I think when it comes to things like comparing distributions, I will always talk about, okay, so we look for the highest median, and you talk about it in context, and you look for the lowest interquartile range to look at dispersion, because otherwise they don't know what they're looking for. So I've given them specific things that we look for the highest this, the lowest that, rather than just a general statement. And part B of this wasn't answered well. Again, they were struggling to relate it to the equation. So what do we need to do about that? I think when you see some of the examiners' comments, it is talking about practice and reviewing and learning. So there's some things that students need to learn because it's obvious they didn't know it. And again, it's about context, because for some students, stats will be an add-on to what they're doing in GCSE. For some students, it will be a separate subject. And so that might skew what we see out there when it comes to reviewing scripts and the data, is that it depends on the context of the centres that have done it. But then when you look at the part C, it related to how the researchers could check whether a normal distribution was appropriate. So whilst they were able to say, correctly identified that it could be used to check if it was a bell shape, not enough students did because it didn't perform very well. And others were able to refer to identifying whether the data was symmetrical or checking for skew, but gave no details of what they would actually look for. Again, it felt like that it was the depth of understanding was there, that they've covered it, but didn't really understand it. CI was challenging. I'm assuming that should have been CII. An understanding about the 68% of the data needed to be within 1 standard deviation of the mean. And for those extreme top ends, we should be, as mathematicians, wanting them to understand that kind of stuff. Some students gave a partial description, but failed to refer to the proportions. But very few were able to articulate the link between the normal distribution and the mean, the median, and the mode. So just think about what is it we need to get to our students to understand? What do we need to get them to remember? Within the papers, when we've looked at the feedback in the past, the students were very good at the process-driven stuff. So calculate the interquartile range, draw the cumulative frequency, the stuff that, yes, they're all higher tier topics, but they're good at that because it's process. What I wanted to do with this was talk a bit more about the depth of understanding kind of topics that came through as weaknesses for us nationally. So that was the one. The second one was relative risk. And this was one that, yes, it's the deeper understanding, but there was also seemed to be a real some misconceptions that we can address. So part A, as we would expect, relatively easy. Only a small minority of students didn't put in the correct probabilities. We'd expect that. It's a topic we do at GCSE. But then we get to part B, which is the notation. And only a small minority of students were able to deal with the conditional probability question. Maybe it was the notation, maybe it was the fact that it was conditional probability, but it was answered really badly. Because again, a lot of that is to do with practice, how we do giving them enough opportunity to consolidate that learning. To quote a good old friend of mine is, we don't practice till we get it right, we practice till we can never get it wrong. And I think that's an important thing, especially when students think, oh, I've mastered that, and because they've got one question right. And that might be the case in some topics or some areas of maths that you just think, yeah, that's so simple, I can remember it. But others, and I think conditional probability, especially at the real extreme, is something we've got to have the opportunity in. And I'm going to talk about some of the stuff we've got at the end that I've pulled together that will help us do that. So majority then proceeded to calculate the probability of advanced drivers. Basically, they proceeded to do the wrong thing. So it was the whole conditional probability that they couldn't do. And then there was a number that failed to attempt it. Well, if you put nothing down, you can get nothing in terms of marks. We've got to encourage more and more students, just have a go. We've got nothing to lose. Part C and D were both challenging. Again, I think it's important because we've got to give, like I've said before, we've got to give students the opportunity to practice this kind of stuff. Relative risk was answered correctly by some students, but not all. And I'd looked at previous sittings and relative risk hasn't come out well in any of them. Part C, there was some misinterpretation about what was being asked. And so some of the interpretations were not very accurate. So be it, like I said, being able to show them worked examples, whether it's your worked examples, whether they're exemplars from the board, of what kind of things should be used or the phrases for interpretation. Students tend to be woolly. One of the points, and if this is the only thing you get out of this hour, I think it's worth it. Students should be encouraged to use bullet points. That's not a bad thing. I think for some students, breaking it down into this, this, and this, when it comes to their interpretations, it is a good thing. And I've started teaching it like that. For those that dislike, for want of a better phrase, wouldn't class them, they would say that they were maths people and so don't like writing long sentences. One of them physically looked like a weight had been taken off his little shoulders when I said it doesn't have to be sentences, it can be bullet points. It was like, really? And I felt so sorry for him that he'd been struggling and stressed about the concept of having to write these massive long sentences. Anyway, I digress. Relative risk is another one. And the idea of what is relative risk? How do we calculate it? Make sure we're giving it the time that it deserves. The misinterpretation. So if you look at C2, they believed that a relative risk of 1.625 was equivalent to 162.5% increased risk, while others thought that 7.4 was equivalent to an increased risk of 7.4% or 740%. So having an idea of what is it that what it means. And then those that have got a value below 1, for example, 0.6, they incorrectly interpret their value as a higher risk of exceeding the speed limit. So it did show a distinct lack of understanding about what those means. And I think, to use an analogy for those of you that teach mechanics A level, it's probably to do with the coefficient of friction, and understand it's not a teaching analogy, but having the understanding about what a coefficient of friction, I can't remember if that's a proper phrase, it's that long since I taught mechanics, what that means, and that the bigger it is, it does this, the smaller it is, it does that. Relative risks of above 1 mean this, below 1 mean that, and just exploring it some more. They've, like I've said, they're very good at the process stuff. So then part D on this, again, it's the interpretation. It came up on the feedback stuff about commenting on appropriateness of conclusions, and it was answered really badly. They didn't consider the proportion of the not newly qualified drivers exceeding the speed limit as a possible reason for decreasing the relative risk. And again, it's a really hard concept for 15 or 16-year-old students to understand, because a lot of the interpretation and risks and the discussions that come through the GCSE stats do require some kind of frame of reference to what goes on in the real world around us. And for some students that haven't got those frames of reference, because they're 15 or 16, it's quite difficult to comprehend. And the next one that I thought, I'm going to produce something to help people teach it, is bias and sampling. Again, the idea of random response technique being something different to random sampling. It came through really strongly that students didn't know what random response technique was, because a lot of the responses were all about random sampling. So my cynical part of my brain went, well, just teach them what it is then. Just teach them stuff. So there is that element of some of this stuff not being taught, or students not having, it's not that it's not taught, they haven't learned it, two different things. And part B, again, it's this commenting on appropriateness. So share them the model answers, show them what words they can use or what statements they can use, show them what is required. But overall, when it came to this kind of topic, make sure they've learned it. Some students suggested a spinner or flipping a cone. There were only a few that were able to reference that the numbers are not randomly generated. Identifying that the numbers were not randomly generated was more commonly seen as a comment than referencing the lack of time frame. So one big thing, talk about random response technique. And then part C was about stratified sampling. In terms of teaching, and I suppose this applies to the GCSE as well, I've just been teaching, luckily enough, lucky me, and I've loved it, sine and cosine rule. And when it came to the rounding, kids are obsessed with, oh, do I need to round it? I say to them, unless you're really confident, you leave it unrounded. You write 110.360 dot to show that you've got an unrounded answer. And there seemed to be, with some kind of errors being made, not some, there seemed to be, there were. So looking at 394 or 393 was the correct answer. There was two correct answers. Otherwise, I wouldn't have put 393 on the solution, because the students were rounding, using a calculator, knowing that major wins for us as teachers, knowing how to use the ANS button on a calculator, and the fact that I don't need to write down 0.16129, blah, blah, and the rest of the number, and then I have to type that back in when I want to use that number. If I'm to know other calculations, I can just use the answer button, or know how to use your memory recall buttons if you have a calculator. So yeah, there's some things there we can learn from it. The premature rounding and any subsequent errors. Sort of nightmare questions to mark when you have to work through, follow through to see where they've got the mistakes. And quite a difficult topic to teach because it's new to them. There's nothing else like this. But that makes it exciting. And for some students, It's lovely that they've got these new topics to be taught. So I thought, let's produce something for this. Let's look at some of the misconceptions. All candidates spoke, well, almost all candidates spoke about it being reliable, but very few mentioned that it could be used to check, because it was, why is it important? And why is reliability important? But again, that's talking about that it does require a level of maturity. Again, showing the sentence starters, what could be used. Most candidates generally recognise that the correlation is positive, but the questions answer the question clearly stated, given interpretation. Students generally were not very good at interpretation or massive wordy responses that were required. So there was no credit given for positive correlation. We needed to see it as income increases, so does life expectancy. But then some students wrote, as life expectancy went up, increases, so does the income. It's about interpreting it correctly. So again, that depth of knowledge, if it's an ad hoc added to exam because they're doing it for an hour a week after school, or they're doing it because they've got 6 weeks prior to an exam, I don't know. It is about context. So then we've got very few students were able to talk about Spearman's rank. And there was lots and lots of blank answers. That one, I would say, yeah, that's probably one you're not going to be able to just waffle on and see, well, I might get a mark for it. So were students not taught it? Was it only taught to the higher? So let's just teach it. I'm not saying it's an easy topic, but if we're talking about the higher tier and stretching the top end, it is one that should be accessible, especially because it will help us when it comes to A level. Then we've got, again, sharing this goes back to that. This is a prime example of why I like sharing those up and down graphs at the beginning, up and down graphs. Doing a statistics presentation talking about up and down graphs, the irony, talking about those performance stats at the beginning, because this shows how it does happen. And students, as long as they're aware of it and they're prepared, because part D, this one, was often the best part of the question, because they knew there was an understanding about the strength of correlation and whether which one had the stronger correlation. So there is a depth of understanding there. Maybe it is just the interpretation and getting their thoughts written down into words. And I have a phrase with some questions about, that's not maths, that's literacy, and about some maths questions, whether it's stats or GCSE. And I didn't realise I said it, but apparently I say it quite a lot, as my year 11 have now started quoting me with a very strong Welsh accent that I've taken exception to. Right, another topic that I thought that I was going to produce something for that will help you, comparative pie charts. And I've got a confession, when I did the solutions for these on one of the papers, there was one question that I had to come back to, because, and it was comparative pie charts. Not because I didn't understand, couldn't get do the sums and the calculations. I couldn't get my head around which words to use when it came to answering one of the, I can't even remember which question it was. And it was this one. I was joking to myself, saying, maybe I need to buy myself the latest textbook. And it was something, it was just something, I had a little bit of a brain fart. My brain just couldn't get it. I couldn't understand it. I get it now, but I think sometimes I had to go through that little bit of cognitive dissonance in my brain where it was just like, I need to battle through it. And knowing how we learn helps, because I'm old enough to be able to say, I know I need to get through it. I need to. So this topic does make me laugh. So most students failed to score well on this. They misunderstood what comparative pie chart was altogether. And so many started talking about that there's not enough information. Some had the right idea, but it was evident there's not enough practice being done. To some extent, I think, yeah, because we're only a few sittings into it, there isn't the resources out there. But those students that did understand the significance of the 60 and the 50, they went on to score the full marks. So as I was looking through all of this, I was coming up with, actually, part of our issue, or a big part of the issue, is the practice, is the consolidated practice. When you look at the research out there, I think there was something published a few weeks ago that got me thinking about problem solving, and that some of the research suggests that students that then go on to answer a similar question, having just gone through a worked example, are able to retain the process a little bit more, or much more, than if there's some time lag between seeing the problem and doing a similar problem. And I thought that was quite interesting. Part B on that question, still not very few students scored full marks. Many scored, they just didn't have a go. The best method on this question was to first find the total frequency for the radio pie chart. It was clear many students weren't attempting to do that as a first step. And so students where they had the correct method, so this is one for me where they didn't have a method. And I think as teachers, sometimes we're scared to go. I was having a conversation with, I'm going to do my little tangent thing I do. We were talking about, well, at primary school, they get taught all these different ways to multiply or all these different ways to do that. And sometimes some students, and you'll know your students better than me, for some students, we will make the call on and go, no, this is the method. This is what we want you to do. Rather than exploring 27 different ways of doing it. And the students sat there going, but which one do I use? So, yeah, and this is clear that maybe, again, that lack of practice was there. Binomial distribution, another higher tier only topic. And I've tried to, again, if I was thinking about the rationale of stuff, when I was thinking about what am I interested in, I'm also interested in those topics that I'm not going to get shed loads of resources for because it's a crossover with GCSE or it's on the IGCSE. I specifically wanted something for GCSE stats and the binomial came out. So when we look at further students got was to achieve 2 marks, was being able to find out the value of P or 3P. Some students misunderstood the question totally and carried out binomial expansions quite needlessly. So definitely worth making sure that we teach that and give it the time that it deserves. I was just then reading that they often use Pascal's triangle. It is a difficult concept, but when you think about, for some students, especially your high flyers, I mean your grade 9, 8, 9 GCSE students, sometimes as they get into the end of year 11, a lot of the maths, GCSE maths they're doing is probably just real stretching stuff. But it would, for some of them, it will be a long time previously that they saw a entirely brand new idea, entirely brand new maths, which it's something like they would see if they were doing further differentiation. Something like the binomial distribution is so that they get their teeth into it. But again, depends on the context of your students. Part B was answered well, and it was obvious that that part had been, so it was almost like, yes, you need to be able to do this. And students knew what to do. So I think the more we do it, and you think, go back to some research done by Ofqual about the sawtooth effect, the fact that as more exams, sittings have gone on, students get used to it. And I think as this go on, we get used to the kind of responses that are required because we get better at teaching it. And it's through things like this event and what I'm going to share with you in a bit that helps us to do that. Again, this appropriateness, students, only a few candidates were able to give the correct explanation with the correct conclusion. So very common theme then, if you're looking for some wins in terms of students, on some topics, being able to assess the appropriateness, they're really good at, like Part B on this. But then in other contexts, and it will that be because they've seen other questions and had discussions about whether or not binomial distribution is appropriate for it. But then on the second part, not so much. So that's a real common theme about this discussion about appropriateness. There's some topics, but what we're going to do about it, I'm going to show you that in a minute. We talked about some of the misconceptions and some of the things we need to address in our teaching. Other areas to focus on. This came out, and I've spoken about this before, but still worth doing from the examiner's report. Using rulers, practice writing. And again, I don't know how many times, if somebody out there should have done a tally chart of how many times I've said practice, depth of knowledge, practice writing clear explanations, answering the question, do they really understand what the question's being asked? So if it's asking you, is it appropriate? Answer that question. Practice interpreting calculations. Overall, those statistical calculations were relatively well done because that's a kind of AO1, using and applying kind of skill. The extended response questions, laying out the answers in bullet points, show that to them, discuss it with them. In terms of topics, they need to look at developing the meaning of skew, conditional probability, and practicing a range of questions, relative risk. So these were topics. And then whilst there was some knowledge, we need to get them to revise it and practice it. Geometric means, more of the different types of sampling, and don't assume everything, the solution to everything is random sampling. Standardized scores, and then looking at skew. There's the themes there about developing their writing, developing their explanations, stuff that we need to make sure is taught well. But then it's all well and good to teach it. We need to make sure they've learnt it, and then they are given the opportunity to revise it and consolidate it. The big thing for me, especially when you look at the response from students, it's those extended responses, the interpret, and just giving them a bank of acceptable sentence starters. So if it says this, you should start your answer with, yes, it's appropriate. No, it's not appropriate, because. So what I've pulled together, and they will be on the Emporium, is a 2, 4, 6, 7 themed papers. One for each of those topic areas that I've just talked through in terms of the performance of students and the students' misconceptions, the examiner's reports, talked about things a little bit in terms of pedagogy and what we need to make sure we're teaching. They will have just gone up, either just gone up or just going up. We've got comparative pie charts. It's all the questions that have been, and I've tried to do it based in date order. So some of them are the earlier GCSE, so the previous GCSE to this, so they're not just this current GCSE, because if they were appropriate, practice is practice. Then we've got the relative risk, a selection of questions and mark schemes. I haven't yet done work solutions, but I will do at some point, so you can use them with your students. For me, this was almost a phase one. Let's get some practice out there. Let's get some practice materials. Sampling and bias. So talking about not just random sampling. Mixed probability is a lovely little paper, even if I do say so myself, because it's got probability notation with Venn diagrams. It's got probability notation with tree diagrams. It's basically probability notation whenever I saw any probability notation. It's a lovely little 45-minute paper. That might be the first one I get done. Scatter graphs, looking at lines of regression. Spearman's rank and Pearson's, and then the binomial distribution. So 7 papers, 7 sets of mark schemes to go with it. There is one there that is, so the Spearman's rank, there was shed loads of questions. So I found 83 marks worth of questions. You can choose them to use in your teaching. You can choose to set them as homework. You can do them in a class. Just use them, because we just need to get more practice material in front of students. And hopefully I've saved you some time from having to go hunting some topic materials for those areas that are just, they're higher tier only. I could have produced stuff for cumulative frequency box plots, histograms, but that's all GCSE. There's stuff out there for that. I wanted something that was particularly specific for statistics, because I think we get a poor deal sometimes. I hope they're useful. So we got 69, 47, 41. Relative risk is a nice, easy one. There's only 15 marks, because there wasn't a lot of material in terms of on Exam Wizard for that. But they are all past questions. So I'm not bringing in supposed expertise. These are materials that have been used in past papers. So yes, they might have seen the questions before, but that's not a bad thing. They might see them if you choose to use them in mocks, but hopefully you will use these after you've done your mocks to consolidate, to review, to make sure and address any poorly performing areas, especially with your higher tier students. I hope they're useful. Don't forget the work solutions. They are all on the Emporium. If you do find a mistake, just let me know, because I'm happy to change them. And when it comes to this, take it with a pinch of salt, but happy to listen to other people when they say, actually, I would always teach that by focusing on this topic or this aspect of the question, or open with this sentence starter. And if you've ever looked at the mark scheme, you'll know that some of the answers have, I don't know, a ream of acceptable statements that could be used. I've tried to use the most common ones that I've seen. And again, you might find that actually my students would never dream of writing that down as the first reason for this being appropriate, whereas my students might, or somebody else's students might, if that makes sense. So, and I've put on the front, other methods may also be awarded marks. It's not a definitive list, but definitely worth using. Familiarise yourself with them, especially if you're new to teaching the topic. And then I thought, I'm just going to have a quick look at grade boundaries. June 21, teacher assessed grades. June 22, June 23, just because I think it's fun to have a look at. On foundation tier, it's, well, to be fair, they're relatively static. There's nothing there that jumps out that makes you outraged about, oh, it's a massive jump, it's a massive decline. I think it's difficult with grade boundaries not to talk to students about them. I always over-egg what they need. So even though a grade boundary may have dropped this year to 89 on foundation for grade 5, I'd still be talking it up and saying, nah, you probably need about 95. Because if the grade boundary was to jump back up to 94, just a word of warning, lots of people got stung when the new GCSE, the second year, because students will work to the level that we all know those students. And I was speaking to a year 11 group today. I said, I know that if I told you needed X, you'd come out the exam, go, Miss, I answered 56 marks worth of questions. And then it would be a shame for us not for the grade boundaries. So I always have high expectations and high barriers in terms of raising those grade boundaries we use internally.